Going to find the explicit equation for a geometric sequence. So if I'm looking at this geometric sequence, I know it's geometric because I'm multiplying by a number by a common ratio every time. And here I can see it in the table and I can see it in the graph. It's an exponential curve here. So we want to take a look at what equation could describe, given any n, what is the actual term number, and n being the place. So if n equals 1, this t of 1 is 3. So it's first place, second place, third place. So that's when given any place, what is the actual term in there? Well, I can take a look at what's happening in my table. So if I go from the first term to the second term, I'm going from 3, I'm multiplying by 2. If I went backwards, so from this, if I wanted to see kind of what the y-intercept was on my graph, I would need to go backwards. So instead of multiplying by 2, I would divide by 2. So I would have 3 divided by 2, which is just 3 halves. So I can write that down here. 3 halves. And then I can use that 3 halves to find any term down here. So for example, let's say I wanted to find term 4. I would just take that 3 halves and I'd multiply it by 2, 1, 2, 3, 4 times. So I would multiply 3 halves times 2 to the 4th. Well, if I wanted to get the 10th term, I would multiply 3 halves times 2 times 2 times 2 times 10 times, so 2 to the 10th. If I wanted to go n times, or however many terms I had, I would multiply that 3 halves times 2 to the nth power. So n 2's here, multiply by 2, 2, 2, 2, 2, 2. And so that would be 3 halves times 2 to the nth power. Now I can see if that works with my table by just substituting some values in there. So for example, if I substitute for n equals 1, so 2 to the first is just 2. 2 times 3 halves is 3. So I can see that when n equals 1, t of 1 is equal to 3. I can do that here as well. So I can substitute in a 3 for 2. So 2 to the third power is 8. 8 times 3 halves, if I do 8 times 3 halves, that's going to be 12. So this 8 and this 2, the 2 from the 8 makes a 1 with this 2, and that's just a 4. So then 3 times 4 is going to give me 12. So I can check to make sure that this equation is going to represent my sequence here when I'm looking at both this in terms of the table and in terms of the equation. And this looks familiar. This looks like our equation for an exponential, which is y equals ab to the x, where a is the y coordinate of the y-intercept, which in this case would be 3 halves, so I could go ahead and plot that. 1.5 there. And b is equal to the multiplication factor. So this is how you write an explicit equation for a geometric sequence. We have here the y coordinate of the y-intercept, and then this is our growth factor or our multiplier.